Hi Math 60. In this video we're going to talk about section 1.6 where we learn about subtraction of real numbers. In 1.5 we learned about addition of real numbers and we learned about the real number model or using the absolute value model to add real numbers. Either one will work for when we're working through this subtraction of real numbers section, so if you don't remember those two models it may help to go back and watch video 1.5. So let's first start out with a definition of subtraction. So for all real numbers a and b, remember that a and b are allowed to be real numbers, positives or negatives, we define subtraction to be the following. The difference between a and b, or a minus b, is defined to be the following: a plus negative b. In words, what this means is to subtract b from a, that's this left side, subtract b from a. What we do is add the additive inverse of b to a. So instead of subtracting b from a, it means the same thing as adding the additive inverse of b to a. So notice here that really what's going on is we're changing the operation from subtraction to addition, but we're adding the additive inverse, right? So the direction of subtraction is still being implied by carrying the little negative here instead of implying a subtraction here. Let's see what we can do in terms of a process. So if we're wanting to subtract some real numbers, first change the subtraction operation to addition, like I just mentioned a second ago. Then change the sign of the number being subtracted. If it used to be a positive number, change it to negative. If it used to be negative, change it to positive. Replace the b with its additive inverse, negative b, is really what this means. Then add using either the rule for adding numbers having the same sign or adding numbers having different signs like we did in section 1.5. And again, you can make use of the absolute value model, or if you like, you can make use of the number line model. So let's try an example. Let's subtract. So 12 minus 15. If we're going to do 12 minus 15, the first thing to do is replace the subtraction with addition, right? Change the sign to addition. Replace the subtraction with an addition. Now we want to replace the number 15 with its additive inverse. So the additive inverse of 15 is negative 15. Okay, so we've changed the sign to addition, replaced 15 with negative 15, which is its additive inverse, and now we perform the addition. So you can either use the absolute value model or the number line model. I will just use the number line model here. So I'm going to start at the number 12, which is 12 units to the right of 0. I want to add the number negative 15, which says to do what? Move 15 units to the left. So draw your number line model, start at 12, move 15 units left, and you will count out that you arrive at the number negative 3. Okay, and again, you can kind of see this intuitively because notice that 15 is a larger number than 12, so our overall answer should be a negative number since there is more negative stuff than positive stuff, yes? That's kind of invoking the idea of the absolute value model when we're thinking like that. Let's try this one down here. Let's subtract negative 3 minus a negative 9. So we start by rewriting the problem, negative 3 minus a negative 9. Change the subtraction here to addition. Change the sign of subtraction to addition. Now we replace negative 9 with its additive inverse. The additive inverse of negative 9 is 9. Now we perform the addition. Negative 3, so I'm going to use the number line model. Start in negative 3 and move 9 units to the right. Why am I moving to the right? Because 9 is a positive number. So on our number line model, if we start at negative 3, move 9 units to the right, that would be what? Start at negative 3, so negative 2, negative 1, 0, 1, 2, 3, 4, 5, 6. Yes? That's why we get a 6 here at the end. Okay. Also, just to use a little bit of reasoning here, notice that 9 is a larger number than 3 is, yes? So we've got more positive stuff than negative stuff, so our final answer should be an overall positive number. So if we have a series of additions and subtractions, if we've got a big long string of them, what should we do? What would be a technique that we could follow? So first, change all subtractions to additions of additive inverses. Do the process that we just described before. Change all those subtractions to additions with the additive inverses of b there. Then group and add all of the positive numbers. sorry, this takes a second, and group and add all of the negative numbers. Once you have those little groupings complete, you want to combine the results of steps 2 and 3. Let's see an example of how this works. Remember with the videos, if you're taking notes as you are watching the videos, you're welcome to pause the video and jot down these notes if you like, or you can also rewind the video so that you can watch other parts again if it went too fast. So let's try an example. We want to do the following addition and subtraction. Big long list of stuff. 7 plus 2 minus 12 minus a negative 3. So the first thing to do is to change all subtractions to additions of additive inverses. So the 7 plus 2, that's not a problem, but this subtraction right here needs to be changed, right? So this minus right here needs to be changed into an addition. We replace this 12 right here with its additive inverse, negative 12. Do the same thing for this subtraction. This subtraction becomes an addition. We replace this negative 3 with its additive inverse of 3. Now what we want to do is group the positive numbers and group the negative numbers. So remember, we're using the associative property of addition as well as the commutative property of addition here. So the 7 plus 2 plus the 3, we're just reordering and putting all the positive numbers near each other, grouping them with the set of parentheses, and putting the negatives over here all by themselves. They're just only one of them. But if there were more negative numbers you were adding, you would group them over here as well. Now we add the positive numbers. 7 plus 2 plus 3 is 12. Add the negative numbers. There's nothing else to add negative 12 to, so it's just negative 12. Now we perform the addition of the two groupings that we did. Negative 12 plus, 12 plus negative 12. When we add 12 and negative 12, we know that they are additive inverses, right? B plus negative B, that always equals 0 when you add additive inverses. Excellent. Let's try an example where you actually have some variables. So let's simplify the following expression. Simplify just means combine like terms for right now. So we want to do negative 5x plus 6y minus 2x minus 7y. So the first thing again is to write any subtractions as additions of additive inverses. This subtraction of 2x needs to be changed to an addition. The additive inverse of 2x is negative 2x. And this subtraction of 7y needs to be changed to an addition of negative 7y. Change the sign of the operation and additive inverse for the 7y. Now what we want to do is rearrange the terms. The reason for this is because we want to add things that are like. We can only add apples to apples and oranges to oranges. So the apples, the x's, we're going to put together all in one box. And the, whatever I said, oranges, the oranges and the oranges we're going to be grouping together here in one big box. Again, making use of commutativity of addition as well as associativity. Now that we have the variables sort of arranged where the like things are near each other, we can go ahead and add them. From here, from this line to this line, we're making use of the distributive property because we're noticing that this x is found in each of the two terms. Or you can think about this as we are adding some x's to each other, which means we just add the coefficients of the x's to each other. Negative 5 plus negative 2. Same thing with the y's. We're adding 6 and negative 7, the coefficients in front of the y's, to each other. Negative 5 plus a negative 2, start at negative 5, go 2 to the left, which is going to place us at negative 7. 6 plus negative 7, start at 6 and move 7 to the left. That's going to place us at negative 1. So our final answer is negative 7x plus negative 1y. All right. Let's go to a final example, just in terms of an application example. So let's notice here that subtraction is often used to solve problems. Actually, it is used to solve problems in which the word difference appears. So the peak of Mount Everest is 8,848 meters above sea level. The Marianas Trench on the floor of the Pacific Ocean is 10,915 meters below sea level. What is the difference in elevation between the peak of Mount Everest and the Marianas Trench? I know they give us the answer right here, but let's see exactly how we work out the answer. I have my little notes sort of pulled up here for us to see what's going on. So just a picture for a second, because it's fun. Mount Everest is a great big tall mountain, right? And actually kind of looks like that. Go me. And then we've got out here in the ocean somewhere this great big long trench, right? Great big deep trench. So we're told that the elevation of Mount Everest here, and I wish I could draw a straight line on here. There we go. That elevation of Mount Everest is 8,848 meters. And then we know that the depth of the Marianas Trench right here, pretend that's a straight line, is 10,915 meters. And our question is, what is the difference between the height of Everest and the depth of the trench, really? So isn't that technically what we're looking for, the height or the length going from this height, oops, not different color, this height all the way down to here, right? We're really wanting to know what that distance is right there, what that length is. Okay, so how we can do that is to rewrite this as a difference problem, right? We want to say, what is the difference between peak of Mount Everest and Marianas Trench? So the difference between height of Mount Everest and Marianas Trench, right? This one over here is Everest. This one is the trench. And this is the difference between the two, right? Difference between Everest and the Marianas Trench. Why is this one negative? Because this one is below sea level. Notice it says below sea level, right? So below sea level for us means a negative elevation, right? Its height is negative. So that's why the Marianas Trench is a negative 10,915. Okay, so it's the difference of 8,848 and negative 10,915. Well, this is a subtraction problem just like we did a second ago. So what do? We change subtraction to addition, and we replace negative 10,915 with its additive inverse, which is 10,915. And now we perform the addition to get 19,763 meters. Pretty impressive. On to section 1.7.